The rapid digitalization of business processes has transformed the role of management accounting from recording historical transactions to analyzing vast quantities of operational and strategic data. Modern organizations generate enormous volumes of information from enterprise systems, online transactions, sensors, mobile devices, and social media platforms. Consequently, management accountants increasingly employ big data and data analytics to improve forecasting, budgeting, performance measurement, customer analysis, and strategic decision-making. The ability to summarize and interpret complex datasets has become a critical competency for supporting organizational competitiveness and evidence-based management. Big data refers to extremely large and complex datasets that cannot be processed efficiently using traditional database systems. The concept is commonly described through the 5 verses: volume, variety, velocity, value, and veracity. Volume refers to the enormous quantity of data generated by businesses through transactions, digital communications, sensors, and online activities. Modern organizations may produce terabytes or even petabytes of information daily, requiring advanced storage and processing technologies. Variety reflects the diversity of data formats available. Data may originate from structured databases, emails, documents, images, videos, websites, financial records, or social media platforms, requiring sophisticated analytical tools capable of integrating multiple formats. Velocity describes the speed at which data are generated, transmitted, and processed. Real-time information generated by online transactions, manufacturing sensors, and financial markets enables organizations to respond rapidly to changing business conditions and customer behavior. The 4th characteristic, value, emphasizes that data itself possesses little significance unless it can be transformed into useful information supporting managerial decisions. Data analytics extracts valuable insights from raw information to improve efficiency, profitability, and competitive advantage. Finally, veracity refers to the reliability, accuracy, and credibility of data. Since managerial decisions depend upon data quality, organizations must ensure that information is complete, consistent, and free from significant errors or bias before analytical conclusions are drawn. Big data can be classified into structured, semi-structured, and unstructured data, depending upon its organizational format. Structured data are organized within predefined fields and tables that can be easily stored and analyzed using conventional database management systems. Examples include accounting records, inventory files, payroll databases, sales transactions, and customer account information. Because of their organized nature, structured datasets can be efficiently queried, summarized, and incorporated into management reports. Semi-structured data possess some organizational characteristics, but do not conform fully to traditional relational database structures. Such data include XML documents, emails, weblogs, JSON files, and metadata, where information is partially organized through tags or labels. Semi-structured data require more advanced processing techniques than structured databases, but remain relatively accessible for analytical purposes. Unstructured data represent the largest and fastest growing category of business information. They lack predefined organizational formats and include text documents, photographs, audio recordings, videos, customer reviews, social media posts, and multimedia content. Although more difficult to analyze, advances in artificial intelligence, natural language processing, and machine learning have significantly enhanced organizations' ability to extract commercially valuable insights from unstructured data sources. The increasing availability of big data has transformed management, accounting, through the application of data analytics. Organizations use data analytics to improve operational efficiency, customer relationship management, strategic planning, fraud detection, supply chain optimization, and financial forecasting. Retailers analyze purchasing behavior to personalize promotions and optimize inventory management, while manufacturers utilize sensor data to implement predictive maintenance and minimize equipment downtime. Financial institutions employ analytical algorithms to identify unusual transactions indicative of fraud, while healthcare providers analyze patient information to improve resource allocation and service quality. Consequently, big data analytics enables organizations to make faster, more informed, and evidence-based managerial decisions while enhancing competitive performance. An essential aspect of data analysis involves distinguishing between categorical data and numerical data. Categorical data classify observations into groups rather than numerical measurements and consist of nominal and ordinal categories. Nominal data represent labels without inherent ranking, such as gender, blood group, product category, or customer nationality. The categories merely identify differences and possess no quantitative meaning. Ordinal data, however, possess a natural order or ranking while lacking equal intervals between categories. Examples include customer satisfaction ratings, educational qualifications, or service quality rankings. Although ordinal data can be ranked, the differences between successive categories cannot be interpreted mathematically. By contrast, numerical data represent measurable quantities and are divided into discrete and continuous forms. Discrete data arise through counting and can only assume distinct values, such as the number of employees, defective products, or customer orders. Fractional values are impossible. Continuous data, however, arise through measurement and may assume any value within a specified range, including decimals. Examples include production time, temperature, weight, distance, and electricity consumption. The distinction between discrete and continuous data influences the selection of appropriate statistical techniques and graphical presentation methods. Finally, management accountants employ two complementary approaches to analyzing data: descriptive analysis and inferential analysis. Descriptive analysis summarizes and presents the characteristics of existing datasets through tables, charts, measures of central tendency, dispersion statistics, and graphical techniques. Its objective is to identify trends, distributions, anomalies, and relationships within observed data without extending conclusions beyond the sample examined. In contrast, inferential analysis uses statistical methods to draw conclusions about an entire population based upon a representative sample. Techniques such as hypothesis testing, confidence intervals, regression analysis, and correlation analysis enable management accountants to estimate future behavior and support forecasting under conditions of uncertainty. By combining descriptive and inferential methods with big data analytics, organizations can convert complex datasets into meaningful management information that supports planning, control, strategic decision-making, and long-term organizational performance.